Assalamualaikum and greetings to all the viewer and Dr. Susanna. We are from Group 2 presenting our project-based learning entitled Trees and Ground Extraction of Bamboo Avenue using Classification and Segmentation of Terrestrial Laser Scanning. This project was carried out on Monday, 19 December 2022. The main objective of our project is to perform the classification and grouping as well as segmentation of existing physical features, which is trees. Traversing method has been implemented during the scanning. The doom technique has been applied during scanning with 30mm/10mm accuracy, where it scans 360 degrees horizontally and 270 degrees vertically. At least 4 ground control point is established by using GNSS observation. This ground control point is used for georeferencing purpose. The coordinates are observed using the MyRTConnect method.
I will present about job scope. So our study area is at Bamboo Avenue. So in this job, we use TopCon JLS 2000 as a main instrument to collect the data around the Bamboo Avenue. This laser scanner allows to quickly and accurately capture 3D data that have a few features for the instrument, which are high accuracy, long range, dual camera, and others. Next, data will be processed using Vernacular software. The software is a post-processing software for TopCon data solution. The cloud data can be created by registering scan data measure from multiple occupation points in a various method. We can also carry out removal of unnecessary point, adjustment of cloud density, data cleaning, and data output in a various data format. Finally, we move to the data processing using the cloud compare software for the data classification. It can also handle triangular mesh and calibrate image. We use the software to classification with Konupo that have several steps, which are subsample classes, create a trend classify the cloud, filter point by value, and lastly clean up final ground cloud.
After finishing collect data from the field, we will proceed to laboratory for pre-process the data using Vernacular software. So why we use Vernacular? This is because we using TopCon DLS 2000 when data TopCon is in .cps were only compatible with Vernacular. In this pre-process, there are 3 important steps to do, which is registration, filtering, and converting. To enhance your understanding, let's go first with registration. Why we do registration? Registration is to register all the data of each website to overlap the data without the hole. So why the data have to be registered? So that the data can be at their original true coordinate and then can be used of each website. Of course, we have to check whether residual RMSE can be used or not. To know if the residual can be used is under 10 mm. The second step is filtering. For example, filtering is where you remove all the noises and then unnecessary point from the data. At our project, we are removing all the road and tree from the Bamboo Avenue so that we can focus on classify only that part. And the third step is converting, where we convert the data from .cps to .las format so that the data can be used in Cloud Compare.
Firstly, the data processed from the manual collage will be imported to Cloud Compare software for further processing. A manual classification is processed with high-res features. In this stage, it is important to pick a relevant classification value with scalar fields of histogram. This histogram has assisted us in choosing which attribute to classify. To prevent failure, students should carefully choose the layer process to avoid from processing different features. The classification can also be processed automatically with CSF plugin, where it is a more robust alternative. CSF plugin requires a large dataset in scale. Once every step mentioned has completed, the software will automatically classify the point cloud. Next, to achieve the project objective, the segmentation will be conducted in order to separate the ground and vegetation attributes. The main function of segmentation tools had allowed us to separate the point cloud to match our needs. Once the trees were detached from the ground, this data outcome can be used for any other purpose in advance, such as in collecting information of the trees, like diameter of trees. This data segmented could be exported as an individual point cloud, which found useful in landscape planning, for example. An adjustment of color has split our data between the trees and ground and resulting as individual attributes.
Next, there are obstacles and some challenges we have faced in getting the result from the project work we are doing. The first is that when we carry out the data collection process, there is a problem in the coordinate parts, that is in the coordinate value in the TLS tool is far different from the coordinate data while taken with GPS. After that, the device is already damaged and cannot be used. Next, the other problem we face is that it is one of the mistakes commonly called human error. It is wrong to enter the coordinate in reverse. This gives the effects when processing data in magnet collage that the data taken is reversed from what it should be. In addition, there are also many other problems during data processing which are a problem in terms of time and also our understanding in solving them.
Hello, so now I will proceed with conclusion and recommendation. As for our conclusion, generally our group has successfully achieved objective of the study. We somehow has accomplished to classify the physical features such as trees at Bamboo Avenue. Our data collection was conducted very smoothly with guidance with Encik Faizi and Dr. Susanna. We could say that we really appreciate to get the chance to experience this. However, classification using Cloud Compare is done manually, without plugins such as Canopo. This is one of the features that we have explored during the processing. Though we were facing the challenges, we still managed to perform the processing using Cloud Compare. These challenges has led us in gaining exposure of data processing of terrestrial laser scan. Last but not least, we hope that our outcome generated could be beneficial for research purpose in advance. It could be used as proprietary data for landscape purpose, such as in gathering information regarding the species of trees planted or diameter of the tree. Though the result wasn't that satisfying, we believe the incoming students could make an improvement from this project. That's all from us. Thank you.